my name is Alma, and we're going to learn about air pollution.
So going into our atmospheric unit, first we're going to just kind of do an overview of air pollution, just to kind of get our footing and what we're going to be talking about. I'm not going to go into super detail about the photochemical smog in this little part. I'm going to do it later on in the PowerPoint because I'm going to talk about it in detail along with acid rain. So, I'll kind of breeze over it at first and then go deeper into it. So here we go. So when we talk about air pollution, there are two kinds of air pollutants really. There's primary pollutants, which are pollutants that are emitted directly into the air. So it can happen naturally, like from a volcano, or anthropogenically through cars or smokestacks, whatever it may be. But those are any pollutant that's emitted directly into the atmosphere, just the way that they are. That's called a primary air pollutant. So we look at particulate matter, nitrogen oxides, sulfur dioxides, carbon dioxide and carbon monoxide, and VOCs. And so, right, all of these are actually emitted directly. Or on the other hand, you have secondary air pollutants, and the secondary air pollutants are pollutants that come from primary air pollutants that have reacted in the atmosphere with other molecules, whether it be oxygen or water vapor or whatever it may be. But these pollutants are pollutants that come after the initial emission. So in the picture here, and like I said, I'm not going to go super into it, but tropospheric ozone or ground level ozone is a secondary pollutant. You don't have a fossil fuel electric plant pumping out ozone. It's what they are putting out into the atmosphere, or the nitrogen oxides that actually cause the formation of ozone, which you will see in detail in just a little bit. Here's a little picture for your viewing pleasure. You have primary and secondary air pollutants. Again, right, the primary air pollutants are directly out into the atmosphere, and secondary air pollutants come from those primary air pollutants and something else in the atmosphere reacting and forming a new molecule. Just to go through our major air pollutants, we'll start out with particulate matter, or PM10. So that 10 is a subscript. A lot of times you have PM 2.5, which is actually even worse, but we'll talk about that in just a minute. But basically, the smaller the particulate matter, the more damage that it can do to your lungs, basically. And PM10 is where you really start getting some issues. And the 10 means micrometers. Yeah, micrometers. Anyway, right, this could be smoke, dust, diesel soot, lead, in asbestos, really anything that is airborne, as long as it's a small particulate matter. It can come from the combustion of wood. We talked about this before, where there's a lot of soot that comes from biofuels. Diesel vehicles also have a lot of particulate matter. And then, volcanoes with the ash, or forest fires, dust storms, all of those fine particulates can get into the lung and cause a lot of trouble. So not only is it a lung irritant, but it also can be something that's not as serious, like reducing your visibility, like it's annoying. But depending on what the particulate matter is, it could actually be some sort of carcinogen. And so that's not good, right? So there's asbestos, and not only is it irritating in the lungs, it can also cause cancer. The smaller the particulate matter, like I said, the more hazardous it is. And right, the particulate matter of 2.5, so the even smaller kind can get deeper and deeper into the lungs. And so, they have a greater health concern. So nitrogen oxides, or NOx, remember that subscript X denotes a number. So in this case, it's 1 and 2, right? And nitrogen oxide and nitrogen dioxide, and they go back and forth pretty easily from one to the other. But basically, all combustion leads to nitrogen oxides. There's lots of natural sources, but nitrogen oxides are formed basically anytime you burn any kind of fossil fuel. Motor vehicles, any kind of stationary plant that's actually combusting fossil fuels, such as a power plant, whether it be, coal or oil. And nitrogen oxides are really important. You guys are going to see this when we get into smog in just a minute. But nitrogen oxides play a massive role in forming ground level / tropospheric ozone. So that leads to the formation of photochemical smog. Like I said, we're going to go over that in detail. It can also form nitric acid in the air when it reacts with water vapor. So you have this acid deposition as well, or acid rain, as you might call it. I'm going to call it acid deposition because you're depositing acid, whether it is through rain or some sort of precipitation, but it's that acid coming down. Anyway, nitrogen oxides in and of itself can do all kinds of things. It's a lung irritant, and this is kind of like, right, if it's like, what is a human health effect of any kind of air pollution? Like lung irritation. Boom, got it, done, right? So stock answer. But basically, it can hurt your lungs, suppress plant growth, and then, of course, nitrogen oxides can be a carcinogen. So next up is sulfur dioxide. Sulfur dioxide itself is a corrosive gas. So you can see these plants on the bottom here have been damaged by just sulfur dioxide. And it primarily comes from the combustion of fossil fuels. So majorly coming from diesel fuel and also from burning coal. So any fossil fuel that contains sulfur, if I add oxygen to it, I'm going to get sulfur dioxide as a byproduct. This is a massive component in acid rain as well, or acid deposition, because that sulfur dioxide combines with water vapor to produce sulfuric acid. That's not good. Oh, and look, there it is again, right? Sulfur dioxide can be a respiratory irritant. Yet again. See, I told you. You have your carbon oxides. There's carbon monoxide and carbon dioxide. So carbon monoxide is formed during incomplete combustion, so it's just not burning as well. And their vehicles and industry, they have a lot of carbon monoxide. It's one of the major indoor air pollutants. If you don't have a carbon monoxide detector, you may want to go and get one, because everyone should have one. It's what they call the silent killer, because carbon monoxide actually bonds with the hemoglobin in your red blood cells, and so that makes it not available for your red blood cells to carry oxygen, and so you're basically suffocating without feeling like you're suffocating, and it's kind of people don't realize it and they fall asleep, and that's not good. Let's see. Oh, carbon dioxide, of course, is a greenhouse gas, which we'll talk about, well, actually, we're not going to talk at length in this particular unit, because carbon dioxide is not considered a criteria air pollutant according to the Clean Air Act, which we'll talk about in just a moment. But carbon dioxide is also formed in combustion of fossil fuels and biomass. And carbon dioxide has lots of natural sources like volcanoes and cell respiration. So, right, it's a byproduct of respiration, and it's taken in through photosynthesis. So you guys know your carbon cycle. I'm not going to go over it, but you should. And carbon dioxide's been increasing because, like I said, it's not regulated through the Clean Air Act. And here is this very familiar graph. Hopefully at this point, right, the trend in carbon dioxide as we've been going forward since the 1960s here. Carbon dioxide has been increasing a lot. And there's this seasonal variation because of the seasonal change, right? There's more photosynthesis happening in the starting in the spring into the summer, and then the carbon dioxide actually starts to increase again in the fall because the leaves are falling off, and you are not, or the plants, not you, right? The plants aren't going through as much photosynthesis in the fall, winter, and so you have higher levels of carbon dioxide, or rising levels of carbon dioxide through the winter. And yeah, so you guys should know this graph, and I've showed it to you many times, so I'm just gonna go ahead and move on now. Another air pollutant is called volatile organic compounds. Basically, it's any organic compound that evaporates really easily. So probably on a paint can, you'll see that a paint has low or no VOCs. But like that smell of like gasoline or any kind of solvent or whatever it may be, right? If it has that really strong smell, most likely that's VOCs. They're not good for you. Most are carcinogenic and are, just bad for you all over. And VOCs is actually another component of photochemical smog as well. Ozone, or I would say ground level ozone or tropospheric ozone, is a major component of photochemical smog. I know I keep saying it, that we're going to go forward and learn about it, and I promise we will. We're almost there. But ozone in and of itself can be another lung irritant. It can cause damage. It can be an eye irritant. If you look at the weather report, usually in the air quality index, it'll tell you ozone levels are high. That's not a good time to go outside. Usually it happens in the summer, which we'll talk about why in a moment. Yeah. So the Clean Air Act, right, actually protects air quality. And so before the Clean Air Act, there were no regulations on what industry could put out into the atmosphere. And by putting this legislation into place, Congress directed EPA to come up with standards to protect human health against these 6 criteria air pollutants. And so you have NOx, ozone, sulfur dioxide, carbon monoxide. Note that carbon dioxide is not there. Lead and particulate matter. And so a nice, fun little tool to help you remember it is nose clip, NOSCLP, right? Nose clip. NOx, ozone, sulfur dioxide, carbon monoxide, lead, and particulate matter. And right, the Clean Air Act has been, like I said, has been huge in really human health and saving people's lives. Right, if you breathe it in and it's not good for you, you will get sick and you could possibly die, right? So by lowering certain amounts of pollution, we're able to really save a lot of lives. And it's all about human health. So that's something I really want to put forward, is the EPA's number one reason for being, really, right? Their primary cause for putting certain laws into places for human health. For example, the Clean Air Act led to a massive reduction in atmospheric lead. If you go to the gas pump, you'll see it says unleaded fuel, right? And that's because gasoline actually used to have lead in it. And so when you combust it in your combustion engine of your car, you have atmospheric lead being put out into the atmosphere. Wait, but you got it. Anyway, right? So by taking that lead out of the gasoline, and instead now we use ethanol, right? That lead wasn't there, and it's not going through the combustion engine, and we've reduced the amount of lead in the atmosphere. Yay!